Hello everyone, welcome back to A Kids Academy. Today we are going to learn the chapter Metals and Non-Metals, Chapter 3, Class 10 Science, CBSE Chemistry. Let's go to the first slide. As we all know, in this materialistic world, all the items around our surroundings, majority of the items are made up of metals. For example, the chairs that we sit on, fan blades, the hangers, and even the almiras, etc. Many of the items are made up of metals, so we can understand that metals and non-metals are the fundamental building blocks of the material world around us. In this chapter, we'll understand their properties, differences, and applications is crucial in various fields from chemistry to industry. Elements in the periodic table are classified into two broad categories that are metals and non-metals. Let's go to the next slide. Before we get to know about the properties of metals, let's see what are called metals. Those elements which form positive ions by losing electrons are called metals. For example, copper, iron, aluminium, sodium, etc. Now let's see the physical properties of metal. Metallic luster is the first one. In pure state, metals have a bright shining surface. This property is called metallic luster. Metals like gold, silver and platinum are known for their shining surface. Hardness. Most of the metals are hard. The hardness varies from metal to metal. Some alkali metals like lithium, sodium and potassium are so soft that they can be easily cut with a knife. Third property is ductility. Metals are generally ductile. It is a property due to which a metal can be drawn into thin wires. Gold is the most ductile metal. Point to be noted, due to this property, gold is used for making jewelry items. Fourth property is malleability. Most of the metals are malleable. It is the property of metal due to which it can be beaten into thin sheets. Gold and silver are the most malleable metals. Fifth property is electrical conductivity. Most of the metals are good conductors of electricity in solid state. However, conductivity may vary from one metal to another. The conduction of electric or flow of electric currents occurs due to the flow of free electrons present in the metal. Sixth property is good conductor of heat. Generally, metals are good conductors of heat, except lead and mercury, which are poor conductors of heat. Metals like copper and silver are the best conductors of heat. Seventh is melting and boiling points. Metals generally have high melting and boiling points. Tungsten has the highest melting point among metals, while gallium and caesium have very low melting points. These two metals will melt if we keep them on our palms. Point to be noted that due to this property, tungsten is used to make the filaments of the bulb, as it has the highest melting point among the metals. Eighth property is the sonorosity. The metals that produce a sound on striking a hard surface are said to be sonorous. Using this property, school bells are made up of metals. Now let's see what are the chemical properties of metals. First is reaction of metals with oxygen. Almost all metals combine with oxygen to form metal oxide. For example, metal plus oxygen is metal oxide, and another example, aluminium forms aluminium oxide when heated in air. Similarly, when copper is heated in air, it combines with oxygen to form copper oxide, a black oxide. Generally, metal oxides are basic in nature, exception. Some metal oxides such as aluminium oxide, zinc oxide show both acidic and basic behavior. Such metal oxides which react with both acids as well as bases to produce salt and water are called amphoteric oxides. Example, aluminium oxide reacts with acids and bases in the following manner. Aluminium, aluminium oxide acting as basic oxide plus hydrochloric acid gives us aluminium chloride plus water. Aluminium chloride plus sodium hydroxide gives us sodium aluminate plus water. Metallic oxides are insoluble in water, but some of these dissolve in water to form hydroxides known as alkali. Now let's go to the next slide. Now let's see what are the properties of nonmetals. In contrast, nonmetals have properties opposite to metals. So Generally, nonmetals are non-lustrous, brittle, and poor conductors of heat and electricity. Some nonmetals exist as gases, while others are solids, for example, oxygen, sulfuric acid, etc. Now, let's go to the next slide. Now let's see some facts about metals. Gold's malleability. Gold is so malleable that a single ounce can be stretched into a wire 50 miles long. This incredible ductility and malleability make it a favorite for jewelry and electrical conductors. Iron's cosmic origin. Most of the iron on Earth was formed in supernova explosions. It is a reminder that the materials we use daily have cosmic origins. Copper's antibacterial properties. Copper surfaces have natural antibacterial properties. They can kill many harmful microorganisms, making copper an essential material in hospital and healthcare settings. For that reason, our elders suggest us to use copper bottles and copper utensils while we are eating. Point if you know it, curd should not be stored in copper utensils. Some more facts about metals. Lead's historic use. Ancient rooms used lead extensively from pipes for plumbing to makeup. Unfortunately, information is highly toxic and its uses leads to health problems for those who use it. Aluminium's lightweight nature. Aluminium is incredibly light. It's one third the weight of steel, yet it's solid and durable. This fact makes it an essential material in the aerospace industry. Mercury's unusual state. Mercury is the only liquid metal at room temperature. Its unique properties have made it worthwhile in thermometers and scientific instruments. Titanium strength. Titanium is solid and corrosion resistant. It's often used in medical implants, aircraft, and sports equipment like bicycle frames. Platinum's rarity. Platinum is one of the rarest metal on earth. Its scarcity contributes to its highest value and it's often used in jewelry, catalytic converters, and as a store of value. Silver's antibacterial properties. Like copper, silver has natural antibacterial properties. It has been used for centuries to sterilize water and dress wounds. Tungsten's high melting point. Tungsten has the highest melting point of all metals, reaching over 6,000 degrees Fahrenheit, 3,422 degrees Celsius. This property makes it essential in applications requiring high heat resistance such as light bulb filaments and rocket nozzles. Now let's see some facts about nonmetals abundance in the Earth's crust. Nonmetals comprise a significant portion of the Earth's crust. Oxygen in particular is the most abundant element, containing approximately 46% of the Earth's crust by weight. This abundance has profound implications of the composition of the planet and chemical processes that shape it. So if you all like to look at this, some facts about nonmetals, but still they're not connected to our chapter. If you are interested to look at these facts, please have a look. Now let's go to the next slide. Here are some more facts. If you like, you can take a look. Let's next slide. Yeah, before we discuss about occurrence of metals, I would like to discuss about two more topics. That is reaction of metals with water. Metals react with water and produce metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolves it in it further to form metal hydroxide. All metals do not react with water, as the metals placed lower in the reactivity series are less reactive towards water. And third would be reaction of metals with acids. Reaction of metals with dilute hydrochloric acid, except a few less reactive metals such as copper, Ag, Au, Pt, and Cu, etc. All metals react with dilute sulfuric acid and hydrochloric acid to produce salt and hydrogen gas. Point to be noted, the rate of formation of hydrogen gas bubbles decreases in the order magnesium, aluminium, zinc, and Fe. This shows the decreasing chemical reactivity of the given metals with dilute hydrochloric acid. Next is reaction of metals with dilute HNO3. Hydrogen gas is not evolved when a metal reacts with nitric acid. This is due to strong oxidizing nature of nitric acid. It oxidizes the H2 produced to water and itself get reduced to any of the nitrogen oxide, but magnesium and manganese react with very dilute HNO3 to evolve H2 gas. Now let's see next thing, that is reaction of metals with solutions of other metal salts. Reactive metals can displace a comparatively less reactive metal from its compounds in aqua, aqueous, aqueous salt solution or in molten forms. This type of reaction is called displacement reaction. Now I would like to tell about anodizing. Anodizing, it is the process of forming a thick oxide layer on the surface of aluminium. Aluminium develops a thick layer of oxide when left in air. This oxide layer is protective and prevents the metal from further oxidization. This layer can be made more thick by anodizing. In this process, clean aluminium particle is taken as anode and dilute H2SO4 as an electrolyte. When electric current is passed, O2 gas gets liberated, which reacts with metal aluminium to form a thicker layer of oxide on its surface. Now let's see what are non-metals. So those elements which form negative ions by gaining electrons are called nonmetals. For example, iodine, sulfur, oxygen, hydrogen, etc. The nonmetals are either solids or gas except bromine, which is a liquid. Now let's see what are the physical properties of nonmetals. Malleability and ductility. Non-metals are neither malleable nor ductile, thus they cannot be beaten into thin sheets or drawn into wire. Brittleness. Non-metals are brittle in nature. For instance, sulfur is a brittle solid. If it is hammered, it breaks into pieces. Physical state. Most of the non-metals are soft if solid. Only diamond and allotropic form of carbon is the hardest known substance. Luster. Non-metals don't have luster, thus shining surface. However, diamond, graphite, the allotropic forms of carbon and iodine have luster even though they are nonmetals. Electrical and thermal conductivity. Nonmetals are generally poor conductors of heat and electricity. Graphite, an allotrope of carbon, is a good conductor of electricity. Melting and boiling points. Generally, nonmetals have low melting and boiling points, but nonmetals that are solids have comparatively higher melting points. Point to be noted, the non-metals are either solids or gas except bromine, which is a liquid. The gases like nitrogen, oxygen, carbon dioxide, etc., which constitute air, are all poor conductors of electricity. Now let's see about the occurrence of metals. So the Earth's crust is a major source of metals. Seawater also contains soluble salts like sodium chloride, magnesium chloride, etc. Now let's see about the reaction between metals and non-metals. Ionic bond formation. Each metal wants to have completely filled valency shield. Thus, it wants to have either 2 or 8 electrons in their outermost shell. Metals have a tendency to lose electrons to form cations plus V positive ions, and non-metals have a tendency to gain ions to form anions, negative ions. When metals and non-metals react with each other, then both of them tries to achieve completely filled outermost shell by transfer of electrons. This type of chemical bond formed by the complete transfer of electrons from one atom to another is called ionic bond. Such compounds are called ionic compounds. For example, electric configuration of sodium, which is a metal, is K shell, it has 2, L shell, it has 8, M shell 1, and in order to complete this octet, thus 8 electrons in the outermost shell, it is easier for sodium to lose 1 electron from the M shell rather than accepting 7 electrons in it. Thus it has tendency to lose 1 electron to have completely filled valency shell. Similarly, if you see the electric configuration of chlorine, K2L8M7, which is a non-metal, we found that it's easier for chlorine to gain 1 electron in its M shell rather than losing 7 electrons from it. So it has a tendency to gain electron to have completely filled orbitals. Now let's see what are the properties of ionic compounds. First is physical nature. Ionic compounds are hard, crystalline solids because of strong forces of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Second is melting and boiling points. These compounds have high melting and boiling points as large amount of energy is required to break strong ionic attraction. Solubility. These compounds are soluble in water, polar solvent, and insoluble in inorganic solvents, non-polar solvent like kerosene, benzene, ether, petrol, etc. As water is polar in nature, it helps in separation of oppositively charged ions from their ionic compound. Fourth is conduction of electricity. The conduction of electricity through a solution involves movement of charged particles. Ionic or electrovalent compounds are good conductors of electricity, but they conduct electricity either in molten form or in their aqueous form. A solution of an ionic compound in water contains ions which move to the oppositively charged electrode when electricity is passed to this. Now let's see the next slide. So we have discussed about the properties of ionic compounds. Now let's go to the next slide. So now let's come to the topic, that is alloy. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. It's prepared by mixing the metals in molten form and then cooling the mixture. The electrical conductivity and melting point of an alloy is less than that of pure metals. Example, brass, an alloy of copper and zinc, and bronze, an alloy of copper and tin, are not good conductors of electricity, whereas copper is used for making electric circuits. Solder, an alloy of lead and tin, has a low melting point and is used for welding electric wires together. If an alloy contains mercury as one of its components, it is called amalgam. Example, sodium mercury amalgam, silver mercury amalgam, etc. Now let's see what is the wonder of ancient Indian meteorology. The iron pillar near Qutub Minar in Delhi was built more than 116,000 years ago by iron workers of India. They had developed a process which prevented iron from rusting. This is due to the presence of thin layer of magnetic oxide Fe3O4 on the surface. For its quality of rust resistance, it has been examined by scientists from all parts of the world. The iron pillar is 8 meters high and weighs 6 tons, 6,000 kg. Now let's go to the next slide. So as we have learned in the first chapter what is corrosion, let me tell what is corrosion again. Corrosion, it is the slow process of eating away of metals by the reaction of atmospheric air and moisture. Example, rusting of iron, tarnishing of silver, formation of green coating over copper, etc. Now let's see how we can prevent corrosion. Rusting of iron is prevented by galvanization by making alloys, painting, greasing or oiling, and tin plating and chromium plating, which are explained below. Now I'm going to explain this. Galvanization, it is the process of coating iron and steel objects with a thin layer of zinc. It is done by dipping the objects in molten zinc. The galvanized article is protected against rusting even if the zinc coating is broken. Alloying, it is the method of improving the properties of a metal by mixing the metal with another metal or non-metal. Alloying of iron. Pure iron is very soft and stretches easily when hot. It is mixed with a small amount of carbon, about 0.05%, and becomes hard and strong. Iron is mixed with many metals to form different alloys. For example, when iron is mixed with nickel and chromium, stainless steel is formed, and which is hard and does not rust. Alloying of gold. Pure gold is very soft. It's called 24 karat gold to increase the strength and hardness of gold and to make it suitable for making jewelry. Alloy of gold is made either with silver or copper. Example, 24 karat gold means 22 parts pure gold mixed with 2 parts of copper or silver. Now let's go to the next slide. Now let's see about extraction of metals. First is roasting. It is the process in which a sulfide ore is heated below its melting point in the presence of excess air to convert it into metal. Second is calcination. It is a process in which a carbonate ore is heated below its melting point in the absence of air to convert it into metal oxide. Third is reduction of oxide ore. It is the process of conversion of metal oxide or metal oxide ore into metal. It can be done by heating the oxides with suitable reducing agents like carbon in the form of coke. Sometimes displacement reactions can also be used to reduce metal oxides to metals. The highly reactive metals such as sodium, calcium, aluminum, etc. are used as reducing agents because they can displace metals of lower reactivity from their compounds. These displacement reactions are highly exothermic. The amount of heat produced is so high and the materials are produced in the molten state. The reaction of iron oxide with aluminium to produce iron is to join railway tracks or crack the machine parts. This process is called thermite welding. This reaction of metal oxide to form metal by using aluminium powder as a reducing agent is known as thermite reaction. Now let's see, go to the next slide. Okay, before I would like to end my this class, I would like to even explain about refining of metals. It is the process of purification of the metals obtained after reduction. Various methods for refining are employed, but the most common one is electro-refining. In the process of electro-refining, a thin block of impure metal is used as anode and a thin strip of pure metal is used as cathode. A solution of metal salt to be refined is used as an electrolyte. When electric current is passed, metal ions from the electrolyte are reduced as metals which get deposited on the cathode, and equivalent amount of pure metal from the anode gets oxidized to metal ion and goes into electrolyte and forms. There it goes to cathode and deposit. This cycle is repeated until whole of the metal ion from impure block is dissolved and deposited on cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down below anode and are called and are known as anode mud. Example, in electrorefining of crude copper, here anode is impure copper whereas cathode is a strip of pure copper. The electrolyte is a solution of acidified CuSO4. On passing electric current, pure copper is deposited on the cathode. If you have liked this video, please like and comment. If you have any doubts, please share your doubts in the comments. I will try to answer them. Thank you and subscribe to eKids Academy. Thank you.